Yes, so licenses are extremely important when you will publish your models and try to publish maybe your APIs on top of the models. But then there is an important question, when things are published, is like how you secure your LLM and NLP APIs, when you've built your own model and you build your APIs. So yeah, let's dive into a journey to avoid that data breaches, attacks, and more with Adam and Jared from Cohere. Hello,
hey,
Adam.
well, thanks for having us. Hello and welcome. My name is Ads. I'm a senior security engineer at Cohere, and I've been in the network and security field for around 12 years or so. One of my main jobs at Cohere is to protect our application code as well as other tasks, be it red team or blue team. I'm a current member and contributor of the OWASP Top 10 for LLM project, which is an ongoing initiative to create open standard frameworks for guidance on building and maintaining LLM security.
Hey, I'm Jared. I'm a senior full stack engineer at Cohere. I work on the dashboard, the playground, all the stuff that users see, as well as the APIs behind the scene. I've been here about 2 years, and I've been doing web development stuff for about 10 years. Always been really interested in security and passionate about digital rights like privacy, net neutrality. So fun to see some of that overlap with the new field of AI.
Yeah, Cohere is an AI company that offers a chatbot called Coral, as well as other natural language processing solutions. Our aim of this presentation is to educate the wider community on the topic of LLM API security, as well as we being advocates of the current space. So we kind of want to take a spin, scratch it, run it back a little. We're thinking how best to do this, and instead wanting to give you a spin on our take of the Wild West, a rapidly dynamic space, which is LLM API security. We intend to let you know what we've learned, stuff we've witnessed, what we're currently interested in, and what we might be concerned about as enthusiasts. I spend a bunch of my time outside of work as a security researcher, ethically identifying bugs. So I love what I do. I'm always up for a good conversation. So I encourage you to connect with us after this.
So I'll go over what we're going to be covering on a high level. The aim of this discussion is to highlight some of the rapidly growing NLP and LLM spaces in the AI field. We're also going to talk about common API use cases for these technologies and how security is an ongoing concern with every new technology. We're going to discuss a lot of things at high level, followed by some takeaways from a security perspective. And then we'll do a bit of a deeper look at some examples of common vulnerabilities in LLMs and proof of concepts of things you can see today. So we'll go over some basics. I think many people know this, but just to cover the bases, LLM is a large language model. So these are the driving force behind the current revolution in AI and NLP chatbots, and they're used to power many of the largest language models in the world. And it's the basis of what we work with at Cohere. So some examples of current LLMs that are out there, the Cohere Playground, which we work on, OpenAI's ChatGPT, which you've probably heard of, Google Bard, BERT. There's a lot of stuff going on. The space is growing very quickly, which I think a lot of people are aware of. NLP is natural language processing specifically, which is a branch of computer science that kind of deals with the interaction between computers and humans in natural language. So the goal of LLMs is to enable computers to understand, interpret, and generate human language, which we kind of call NLP as a whole. So some examples that you probably know of: speech recognition, chat assistant, support bots, language translation, but really there's a lot in the field. So just high level, when it comes to LLM APIs, it's basically a large model served through an API and providing endpoints to handle requests. A user would provide text, they'd provide some config. The API would interact with the large model, get a response, and then return generated text or values for whatever you're looking to analyze with text. Common use case might be something like Amazon Alexa when you ask it about the weather.
So basically, we're going to take a spin on this now. What you might be thinking, where does security fit in? which we'll pivot to. So let's start with an external resource. This is not something specifically from a material or a tabletop exercise that we used, but this is a snip of a threat modeling exercise. To threat model, we first need to define what is a vulnerability. A vulnerability to me is a weakness in an information system, procedure, control, or implementation that could be exploited or triggered by a threat source. A threat itself can be identified through the process of threat modeling. We can use this exercise to pre-anticipate, assess vulnerabilities, to remediate and or reduce risk. Threat modeling, as a definition for me, is involving the process of understanding a system's goals from a business objective, mapping out the components responsible for them, and then recursively identifying system and performance criteria down to the essence of the implementation. So what I'm kind of showing you here is a sample of the exercise which could be used when threat modeling a chatbot, i.e. an LLM API, right? The dotted line down the middle of the infographic is the perimeter, which represents the external client interaction with the API endpoint. We label this trust boundary 1, which is a point of potential injection attacks. It's a two-way boundary because we can't always explicitly trust always both the input, being the user's text input or whatever that may be, as well as the LLM's output, i.e. the response to the client. The data can be manipulated from the initial client to LLM interaction and insufficiently sanitized or blocked on the return path. We then have two smaller dotted lines to the right of an infographic, kind of going a bit further, which represent the internal infrastructure where our API endpoint hooks into our ecosystem. Trust boundary 2, as you see in the top right, needs to mitigate the impact of an LLM passing input directly into an executive function or modifying the presentation of a cross-site scripting attack payload. Trust boundary 3 needs to mitigate the ability for either the LM or an external user to gain access to sensitive data stores, since by nature, the LMs themselves do not adhere to authorization controls internally. This would be like your classic SSRF or server-side request forgery attack. Moving forward and staying at a high level, what we're doing is we're taking trust boundary 1 and we're using a stride table to illustrate strengths and weaknesses which we can label against that trust boundary. Stride is just one of standard publicly available frameworks, which is common in threat modeling exercises. Each letter in the name corresponds to a specific threat category that can identify strengths and weaknesses in a system and create those theoretical mappings. Stride being spoofing, tampering, repudiation, information disclosure, denial of service, or elevation of privilege.
So let's go over some of the examples of a few attack methodologies and tactics that we're going to talk about in this presentation. So we're going to talk about prompt hacking, which has a lot of different names right now as it's a new kind of area. So some people call it jailbreaks. There's adversarial prompting, but basically messing with prompts when interacting with an AI chatbot. We're going to talk about prompt injection. That's stuff like cross plugin request forgery, package hallucinations, which is a personal favorite because it's so crazy, and then cross-site scripting. Then we'll touch on training data poisoning at the end.
Thank you. So give it maybe the GIF aside. This is a disclaimer. The information contained in this slide is not a direct vulnerability of a specific company, organization, or service. It's recommended to never perform these type of detections without explicit consent. We're not trying to create a double standard here, but effectively just want you all to understand some of the concerns in the space and what we're witnessing as you look to explore building your own API applications that integrate or provide AI solutions. So what we're seeing here is two infographics. At a high level, this is CPRF, which is cross-plugin request forgery. Here we have an example from Embracer Red, which is used to, which is the researcher. The exploit is used to trick an LM into stealing private email information without the user knowing. This is caused by a confused deputy attack. This is where a computer program that is tricked by another program, which has fewer privilege levels or less rights, into misusing its own authority on a system, which is a specific type of privilege escalation. So what does the exploit chain look like? The screenshot on the left, you can see that the attacker hosts malicious LLM instructions, which you can see are literally written in basic HTML here. The malicious instructions manipulate the LLM. On the screenshot on the right, you can see that the victim the victim visits a malicious site with the chatbot-enabled browser plugins, such as like WebPilot is an example, that one way you can integrate that. The LLM reads, interprets the malicious instructions, which triggers a prompt injection, and the instructions of the website can take control of the chatbot. Thus, the chatbot follows the instructions, retrieves the user's email, summarizes it, URL encodes it, and uploads it to a third-party website. And think about the ramifications of this type of attack that could be case with additional instructions, which is wild, like in terms of how broad this potentially could go. You may also be thinking, like, what if the site the victim was not malicious? Well, how do you know that that hasn't been prior injected with embedded instructions that you may not see when, on your average browser, but if you inspect the web page, maybe you find out.
So if there's any developers watching, you may be thinking about cores, because I think in traditional web development, web application development, cores comes to mind when you think about some service that you're using making contact with other services. Cores is basically just used in traditional web applications. It's a way of telling the browser what other APIs it's allowed to contact after contacting your API. But since with LLM APIs, there is the user contacts the API and then the action takes place on the server side, this type of a solution doesn't work as well for this type of mitigation.
So again, playing on the confused deputy, what I'm basically showing is the same kind of attack methodology, but what we're showing here is a lack of verification for user confirmation when enabling plugins, which is spreading to leaks, code repositories, and a similar takeover fashion. So this is another example of the same kind of attack, but just another vector, so it seems. Code injection, what does it look like in code? So this input and output block lists are a method to blocking malicious prompts against generative AI. Scalable methods include machine learning classifiers. Additionally, alternatively, you can use reinforcement learning, which is effectively training a bad LLM to teach a good LLM what is within the guardrails around safety and ethics in ML. What we're showing here is an open source framework of repository, which is designed to simplify the creation of application using large language models used by developers. This is an identified bug shown as a vulnerable chain, which is subject to prompt injection at the code level. Chains are what you get by connecting one or more large language models in a logical fashion. PAL, as you can see from the images, stands for Program Aided Language Model. The PAL chain reads complex math problems described in natural language and generates programs for solving the math problem, but offloads the step to a runtime such as a Python interpreter, while any kind of like specific standardization leaves that therefore increased risk. Another one we're going to talk about here is cross-site scripting and data exfiltration using prompt injection. So similar kind of technique. Basically, what we're showing here at a high level is that the adversary has full control of what the chatbot is doing when a prompt injection occurs. In the exploit, the LLM API returns text. It can return markdown elements, which the client will render as HTML. The LLM API reads directly from the website that is currently being viewed within the browser. The exploit chain would look such as, on the left-hand side screenshot, a malicious bash script is hosted on a remote server. The LLM API is instructed to view the contents from the interaction between the chatbot and the user's web browser. Then the LLM is manipulated by the instructions present to perform actions which result in a cross-site scripting attack. I really encourage you to kind of further check out the POCs here, which actually some of them do include video demos, so you can get a better kind of illustration when you have additional time to go through that.
So I'm going to talk a little bit about LLM hallucination. I actually find this one pretty fascinating. But basically, LLM hallucinations are just when a large model makes stuff up or confirms things to be real that aren't real. And there's a pretty interesting attack where a hallucination can be taken advantage of. In a similar way to like an NPM supply chain attack or any sort of package manager attack where somebody trusts a package and it gets taken over by a new owner and there's an exploit added, or a package is artificially added and built up so that people add it to their projects, and then that's an attack vector. So when it comes to APIs that work with LLMs, how does this work? Well, basically, what will happen is an attacker will go and look, try to make generations for code requests and look for hallucinations that talk about packages or resources that don't exist. They'll then verify that there's no package like that, and then they'll go and publish the package themselves, adding their own software into there or code, and basically masquerade it as a legitimate package, hoping that the hallucination continues for new users. So then a legitimate user will ask the same question. They'll get the same hallucination, but now there's a real package there when they go to download it. And then all of a sudden the user thinks they've gotten information that's very reliable, and it actually is more of a supply chain attack. Basically, even though NLP is a very useful tool and we think it's very valuable and interesting, it needs to be approached in the same way that you approach all new types of software that you're learning about that are being developed, cautiously, thinking about security, and integrating it in a thoughtful way.
Yeah, because I mean, LLM hallucination is LLMs are not perfect, so hallucination is expected. So there's a responsibility on both parties, I would say.
Yep.
So how can we mitigate this risk, or how can we try, right? As an LLM API developer, you can enhance your experience of LLMs with ongoing vulnerability scanning of your models, kind of similar to how you would do with like a traditional web application. Here we're demonstrating the process of certain types of techniques, injection and payloads, which can be tested through LLM vulnerability scanners. Effectively, what's happening is it's enumerating prompt techniques, some of which are shown earlier, to LLM API endpoints against specific probes, which is simply a set of data sets and techniques. Again, just want to kind of illustrate this is not something that we built or I built, but is something going on in the open source community. Again, really quickly, building on the previous slide, effectively illustrating here the basic output analysis from the initial scanning techniques to measure output against input, so we can verify adequate sanitization is being applied on both ends. Think of that as the input and output we described on the perimeter trust boundary. We're back to our threat modeling, right?
So this is an interesting resource. Basically, the Institute for Ethical AI and Machine Learning has put out kind of a mapping between traditional OWASP vulnerabilities to things you can use in a modern ML-based API. So for developers that are looking to kind of get an understanding of the space and map concepts that they're familiar with to new kind of ideas for new threat models, this is a great resource. There's a lot here, but for example, stuff like broken access control mapping to, unrestricted model endpoints. But really, I recommend you go check this out at the Institute of Ethical AI and Machine Learning.
Yeah,
there's a lot there.
It's a great resource. We have traditional API security, but we also need to apply almost like an additional layer at this point. And kind of what we're talking about in the next slide here, we're looking at current frameworks within an early life cycle of a technology which is rapidly developing at scale. So highlighting some of the ongoing efforts to build frameworks and guardrails for security LLM APIs due to the recent acceleration. Many of these are in obviously early stages of development. These frameworks allow us as practitioners and developers to build code and AI applications in all realms of security concerns with best practices and safety and security in mind. Thank you. So how is Cohere participating in the community around LLM security? We're proud to be enthusiastic participants of the DEF CON AI Village this year and to have our LLMs tested by dedicated security researchers. I myself am a contributor of the OWASP Top 10 for LLMs and been selected as part of its core team, which will be going through the final cycles of the project before it finally gets published. It's effectively preparing a top list of large language model projects on an accelerated timetable in response to rapid development and deployment of LLMs in the space. We also embed and bake this wealth of knowledge and expertise into our LLM University and hope to have a security section in the near future. So we're pretty much about time. We'd like to thank you for your time, for having us, listening to us. We had a blast, and I hope you have the awesome rest of your conference. We wanted to kind of allow a couple of minutes. I'm not sure if we have much time for questions, but anything we cannot answer immediately, we request if you can take some follow-up notes, details, and we can get back to you. Again, really encouraged to connect. Yeah, thank you very much.
Yeah, thank you very much. A great presentation. Some comments in the different chats and threads and streams. One question: like, we are organizing a conference on API security called API Secure. So just on API security, and we found that the large industry is not ready yet for just classic REST API or whatever security and now all these new threats. Now a new layer, like, oh man, this is like a new dimension, like prompt injection and hallucination. I don't know, overflow. I don't know how we call them. It's even funny. We're creating the names. Like we're creating the name of the attacks. It's so new, right? It's so fresh.
I mean, like I say, we're enthusiasts, we're advocates. We're obviously watching this space, right? But that's where we kind of go back to things like the threat modeling. We go back to what we know and the available frameworks we do currently have to try and put in what we have in place. As a community together, we can obviously work on those frameworks and build those alignments like we currently kind of have for those traditional web applications, API security. Some of the exploits we kind of went to, I'm sure a lot of developers have kind of dealt with those kind of issues, and they've maybe relied on those frameworks. So.
And additionally, I think an interesting thing in the security space is that threats can be viewed as being very negative, but I think there's a very strong community that's always growing of bug hunters and ethical hackers and that type of thing. And really what that ends up doing is protecting users. So people finding bugs like this means we fix them, and the user is safer in the long run, at least in theory.
Yeah, no, I totally understand. So one question about like the ability for, let's say, a starting company on LLMs and to secure their LLM APIs. Just when you see ChatGPT got leaked, there were 100,000 account leak. It's mostly classic account leakage, but when you see Microsoft integration of ChatGPT, like where they have been able to break the barriers, like the moderation barriers, like even the top players are being tricked. Let's call it like that, right? With their whatever the injections or so. Like, how today a company which doesn't have their size or their means is able to navigate into all what you shared? It's just like hide and seek and just like how they can do that.
I think the some of these resources, like the Institute for Ethical AI one that I talked about, I really like that approach of like, okay, you already think about these types of things. Really, a new space is still security if you kind of map it to the metaphor of like, we're not necessarily talking about cores necessarily, but we're talking about like, think about like how are requests made in whatever space they're in this new. I don't think that's like a full solution, but I think the kind of transcending values of security can move from step to step.
Yeah, I think what we're trying to get across in that slide, but just by mentioning cores, for example, is we're trying to give like a realistic version for what developers who are currently listening to us, enthusiasts in the space, are currently aware of, and kind of apply that same logic, really.
So do you think at some point it's so hard, it's so difficult that actually platforms like Cohere and others will be there to guarantee a certain level of security, if you trust them to host your models?
Sorry, what was the question?
No, the question is like, it seems quite a lot of things to think about. Mm-hmm. And so do you think there is a huge opportunity for a company like Cohere or like yours, right? Your company or others to actually host LLM, and provide it as a service for others, because you will handle security versus if people have to do it themselves.
Oh yes, sorry. So I think I understand. So yeah, as in there will, I expect there will be some kind of rapid acceleration around security companies selling LLM Security as a service, as it would maybe even be labeled, right? Yeah, so I definitely would agree. I think that will be.
Yeah, and I think in kind of the news space, being interested in security over the years, one of the problems is that it's very difficult to get people to think about security, get users to care about security, and I think that the things that work best are like the easy ones, that it's actually easier to do the secure thing than not to. So if you can get someone to actually install a password manager and then use it and have it in their browser, once they get there, it becomes easier. But I think with AI and LLM stuff, especially NLP, some of the responsibility is twofold, where some of it, I think it's an easier space to teach people about security because it's about text and people are interacting not with like, okay, what's this program I'm going to download and use and what are all the security things? And they already don't understand what they're using. Now they're just talking and we're teaching them like, how do you talk safely? Or how do you read safely? Or what are you looking for? So at least my hope is optimistic that it's an easier space to partner with users. But it's a new space, so it's hard to say.
An exciting one.
Yeah.
really exciting, and I think you shared this excitement with all of us. Thank you very much for having been with us at apidays, Ads and Jared, and we'd love to invite you in at other conferences because a lot of good feedbacks on the different streams about your talk. Thank you.
Awesome. Thanks for having us, everyone. Have a great day.